Okay, so the Penalty Anchor, experience of BIT C level 200, and so I present on how primitive and reference data types are managed and accessed in memory. So let's go through our agenda for this lesson. So we're looking at the primitive data types, the characteristics, reference data types and its characteristics, and how data is accessed and managed for both the primitive and then the reference data types. Okay, so the primitive data types, they are the fundamental and building blocks in Java or in it can be any programming language. They're used to store simple values directly in memory. So they are not objects and do not have methods associated with them. Examples include the integer types as for storing whole numbers. Examples are bytes, short, int, and long, and the floating point types. So they are used to store numbers with fractional parts or decimals. Examples are float and double, and the character type that's char. They are used for storing single characters. For example, um, capital A, I, and then the dollar sign. And a boolean type holds two values as true or false. So let's go through their characteristics. So direct value storage. So when you declare a primitive variable, the actual value itself is stored directly in the memory location allocated for the variable, and then it has a fixed size. So each primitive type has a predefined or fixed size in memory, a stack memory allocation. So they are all the primitive variables are stored in the stack memory and then faster access. So due to their direct value storage and then allocation on the stack, it is easy to access, or it is easily accessible. Okay. So the reference data types. The reference data types are fundamentally different from primitive data types. Instead of directly holding the value, they hold a memory address that's a pointer or a reference that points to where the actual value or the actual data is stored in the computer's memory. So unlike the primitive data types, the reference data types it stores their address and then points the object itself to in a different value or a different location. So examples are arrays. So integer array of numbers. So new int 5. So this shows an array of 5 objects. Yeah, so numbers is a reference to an array object. Okay. Classes. So the classes can be string, scanners, array list, date, math, and then system. So these are all examples of classes. So the characteristics. Indirect value storage. As a reference variable doesn't contain the object itself, but rather the memory location where the object resides in the heap memory and the variable size. Unlike primitives, which have fixed sizes, the size of the object can vary depending on its fields and the data it holds. And then slightly slower access. Accessing the actual data of an object requires an extra step as the Java virtual machine first reads the reference or the memory address and then uses the address to navigate to the objects in the heap. Okay. So how data is accessed and managed with a primitive data type and then reference data type. So first let's go through the primitive data types. So the primitives store their actual values directly. They are typically managed on the stack memory, which is fast, organized, last in, first out region. So when a method starts, memory for its local primitives is allocated on the stack. When the method ends, that memory is automatically and instantly reclaimed. Access is direct and very fast. So with the primitive data types, the data is stored in the stack, in the stack memory. Yeah, so for example, if you're having int a equals 5, the 5 is going to be stored on the stack. Unlike the heap where just the address will be stored in the unlike the reference where the address will be stored on the stack, and then the values or the data will be stored in the heap. Yeah. So let's go to the reference data types. So the reference types store a memory address as a reference that points to the actual object. The objects themselves reside in the heap, a larger dynamic region. The reference variable itself can be on the stack, that's for local variables, or on the heap for instance variables. So taking arrays for example, the address of the array will be stored in the stack, and then the objects inside the array will be stored in the heap. Okay, so let's look at this diagram. Let's go through the diagram. So for instance, we're having int a equals 3. So you see that a equals 3 was stored in the stack. Int b equals a. So meaning we are assigning the variable or the value of a to b. Okay, and then when we come down, we saw that the value of b has been changed to 100. So you see here we have b equals 100, and then int array of c equals 1, 2, 3, 4. So the c is going to be stored in the stack. That's the address of the array. Yes, consider the address of the array was that c was stored in the stack, and the object in the array was stored in the heap. So coming down, we saw that the object of or the array of the address of c, the value of c was has been assigned to an array of d. So it's going to contain the same number of elements here. Coming down, we see that um, a new array of 5 values has been assigned to d. So the pointer is now going to change to a different array. We're going to direct or reference a different array with 5 locations. Yeah, no value has been assigned to it yet. And int array of e equals 5, 6, 7, 8. So this is it. E becomes the address, and then the object in the array itself has been stored in the heap. Okay, and then f contains the same number of elements as e, just that the f of or the index 1, as the second index 0, 1, 2, 3. So index 1, that's 6, yes, was been changed to 98. Yes, so always the address of the array or a class will be stored in the stack, and the object in it will be stored in the heap. Thank you. That's the end of this lesson. So again, I'm Luke Chianka, the students of BIT Group C, level 200. Thank you.